Okay, so we're starting into section 2.5, solving polynomial inequations with technology is the title of the unit. I'll kind of show you how to set things up, and then we can use technology if we can't solve them graphically. So today we're going to focus on solving polynomial inequations graphically, and then using technology if we can't solve them graphically. So what is an inequality? Okay, because we're going to be dealing with inequalities a lot. We need to know what they are. So what is a polynomial, or what is an inequality, first off? Okay, so an inequality is something that's not equal. Okay, so what symbols in math do we have for things that are not equal? Okay, what's that? Well, equal sign with the slash, that is it. Okay, so equal sign with a slash, so not equal to, but we can also talk about something being greater than, or greater than or equal to, or less than or equal to. So when we're dealing with polynomial inequalities, these four symbols are going to replace the equal sign. Okay, so it's going to replace, okay. And just so we remember, because we will be using some number lines early next week, if we have a solution that says x is, say, greater than 1, on a number line, if we have -2, -1, 0, 1, and 2, x greater than -1, we put an open circle, and then that way. The open circle means it does not include 1, but it gets very, very close to 1. Okay, so 1 is not in this solution, but 1.000001 is, because it's just a little bit bigger. If we have x is greater than or equal to 1, okay, if we use that same number line, then we are going to include 1 in that solution. Okay, so we can go through an example. We're asked to solve when x squared plus 7x plus 10 is greater than or equal to 0. To solve this inequality, let's treat it like an equation. Okay, so we're going to switch back. We're going to switch back to x squared plus 7x plus 10 equals 0. Okay, and then we're going to treat this just like an equation. Y equals x squared plus 7x plus 10. How could we graph this? If we were asked to graph this quadratic, what would we have to do? We could factor it. So those are going to factor into x plus 2, x plus 5. And then we could find the zeros. So we could say x plus 2 equals 0, x equals -2, or x plus 5 equals 0, x equals -5. Okay, and we could go down and we could get a sketch of our quadratic. We have -2, we have -5. It's a quadratic that's opening up. It's going something like this. So we could say our quadratic looks like that. So we switch it from an inequality over to an equation, and then we're going to switch it back into an inequality. Because our original question asked us when x squared plus 7x plus 10 is greater than or equal to 0. Okay, so if we switch this back into an inequality, we have x squared plus 7x plus 10 is greater than or equal to 0. So let's look on our graph. Where on our graph is our function greater than 0? So we go back to our graph and say, what regions is our graph positive? When is it above the x-axis? We're looking at this. We have it anything to the left of -5. So we could say this equation is greater than 0 when x is less than or equal to -5. As well, it's greater than 0 when when x is greater than or equal to -2. So we've just used a graph to solve an inequality. Okay, so our next example, we're going to try and solve when 2 bracket x minus 1 squared minus 3 is greater than or equal to 5. Okay, and this is a quadratic. Okay, we know it's been shifted to the left 1 and down 3. So it's going to have a shape, oh sorry, to the right 1 and down 3, sorry. So something like that. And we know we want to find out when that is greater than 5. Okay, so this is just a rough sketch. So we'll show you kind of a couple different ways to do that. So the first way, and we'll show you two different ways to solve this. Okay, our first way is going to treat it like an equation. So it'll be very similar to what we just did. So we're going to treat it like an equation and then see what our graph looks like. So we'll treat it like an equation. We'll turn our inequality, our greater than or equal to, into an equal sign. And now we're asked to solve when 2 bracket x minus 1 squared minus 3, when that equals 5. What would we have to do to solve this equation? What would be our steps? So we'd have to get rid of this squared, so we're going to go 2 x minus 1 minus 3 equals 5, and do some work to get that out. So we got 2 x squared minus 2x plus 1 minus 3 equals 5. So 2x squared minus 4x plus 2 minus 3, and in that same step I'm just going to bring that 5 over. Okay, so we can collect like terms there. So we have 2x squared minus 4x minus 6 equals 0. So we go through and we move things over, we expand it, we collect like terms. At this step, you could look for two numbers that multiply to -12 and add to -4, or you can notice that each term is even, so you could take a common factor of 2 out and then look for two numbers that multiply to -3 and add to -2, so you have -3 and +1. Okay, now this one's going to work out nice. We know that our zeros, what are the zeros for this? -1 and 3. It is a quadratic that's opening which way? It's opening up. Okay. And what we've done here is we went through and we changed everything. So now we can take this equation and switch it back into an inequality. We took our inequality that was 2x minus 1 squared minus 3 greater than or equal to 5. And we've been able to manipulate that and change it into when 2x minus 3 x plus 1 is greater than or equal to 0. Okay, so when is this equation greater than or equal to 0? Yep. Okay. The second way we can solve 2 bracket x minus 1 squared minus 3 is greater than or equal to 5. The second way we can do that is to go directly into a graph. Okay. If you're going to be doing this by hand, your graph has to be extremely accurate. So if you're doing this by hand, you need to be extremely accurate, and it's only going to work out Okay, it's only going to work out for integer solutions provided your graph is very nice. If you tried to graph something where they met at say 2.43, you're not going to be able to graph that. Okay, and as you can imagine, the majority of our solutions, or the majority of the solutions that are out there, they're not going to work out at nice numbers because they just represent a small set of the real numbers. These ones will work out nice. So if you wanted to graph these ones, you would graph an equation for 2 bracket x minus 1 squared minus 3. So you go to your graph and say that is my equation for, like that. I could do my points, y-intercepts, x-intercepts, whatever that is. Your second one, you would treat the left or the right-hand side. So it'd be like treat this as an equation and treat this as an equation. So my second one would be y equals 5, just a horizontal line. And then you'd be looking at, all right, well, where is my quadratic bigger than my horizontal line? And then you'd have to determine the point of intersection for the 2 points. So you'd be looking at finding the x value for here and for here. Okay. Again, if you had an accurate graph, you can go down, you'd find out that that one's at, what is it, -1. And the other one is at 3. Okay. If you're using a graphing calculator, you'd put, say, one of those in for y1, the second one in for y2, and using the features of that graphing calculator, you'd have to find the point of intersection. Okay, again,